Greetings and welcome, friends. Today we are continuing our exploration of functions by talking about a specific type of function. Because functions, we agreed yesterday, were any relationship between pairs of numbers in which there was exactly one output for every input. But a linear function is going to be different. So let's find out this. So a linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b, where m and b are constants. Now, when I say constants, Devin, that just means that these are numbers, right? So that might be like a 3 and b might be like a 2. And y and x would then represent every combination of x's and y's that make that equation true. So later on in the course, we'll see functions that have like a squared on it. That wouldn't be linear. That would actually be more like this graph down here. We'll have even like absolute value graphs. We'll see different things, and those will be non-linear functions. All right, but linear functions can be written in this form. All right, it says the graph of a linear equation is a line. It's almost like they named this thing knowing that a linear function was the liniest of all the functions. It has the most line-like graph as a result. So a linear function is a function whose graph is a, non-vertical line. I want to emphasize that. It cannot be vertical, because if it was a vertical line, it would fail the vertical line test. It wouldn't be a function in that case. Okay, so good question, good comment. So if this was my graph, so this would be a function, this would be a function, this would be a function, right? All of these are good, but a vertical line would be a straight up and down line, and this would not be a function, even though it's a line, right? Not a func. So it would be a line, just not function. Because it would fail the vertical line test. All right, so let's look. Let's keep going. Example 1 here. It says identify linear. Oh, did I finish reading that? I didn't. Oh, a nonlinear function. Oh, this is big idea. A linear function has a constant rate of change. All right, constant rate of change, and can be represented by a linear equation in two variables. A nonlinear function does not have a constant rate of change, so its graph is not a line. All right. So based off of, even if I didn't explain any of that, and I didn't explain it really well yet, do you think A is a linear function? No, because it's not a line. No, right? It doesn't look like a line. And when they were talking about constant rate of change, notice this. Look at what this is doing. This goes up 1 and over 1. But notice, if I try to go up 1 and over 1 again, I don't hit a point on my graph. And if I try to go up 1 and over 1 again, I don't hit a point on my graph. It is changing in steepness. Devin, be quiet. It is changing in steepness, right? It doesn't have a constant slope or a constant steepness or a constant rate of change. So this is not a function. Notice that if I did want to find the next point, I would have to go like up 3 over 1 to find a point. And that is more steep than it was just a moment ago. This graph over here is, yes, this is a linear function because it's a line and it's not vertical. It's not straight up and down. And notice the rate of change. All right, if I pick some points on the line where it crosses the grid, those are called lattice points, by the way. I could go up 2 and over 1, and up 2 and over 1, and even over here, up 2 and over 1, and I would always hit another point on the line. This is up 2 and over 1. And it's a constant rate of change, and graphically, it looks like a line. All right, so that's what we're talking about today. So, super quick, let's look at monitoring progress questions 1 and 2. All right. 1, is that a linear function? Yeah, it's a function. It passes the vertical line test. Is it linear? Is it a line? Yeah, it is. Yes. right? And notice it has a constant rate of change. This one's going up 1 over 2, up 1 over 2. It's the same steepness all of the time. Now, how about this one? Is this a function? Yeah, it passes the vertical line test, so it's a function. It has line-looking components in it, except notice it's not constantly steep. On this part, it's up 1 over 1, up 1 over 1, up 1 over 1. But on this part, it's down 1 over 1, down 1 over 1. And so at one point, the slope changed, and so it's not a function, not a linear function. Right? And this is going to be an absolute value graph that we'll see at the end of the chapter. Okay, ooh. We can also determine a constant rate of change. Instead of reading it off of a graph, you can read it off of a table. Okay? Question? Yeah, if it's a line, it's a linear function, yeah. Unless it's a vertical line, right? If it was a vertical line, it's still a line, it's just not a function anymore. Straight across, horizontal is fine. Yep, but straight up and down is a no-go. So Devin, if I wanted to determine whether or not these represented linear or nonlinear functions, the way I would do it is by looking at the change, the rate of change, right? How much is it changing by each time? So check this out. This one is going, right, over 3, right? Each of these are increasing by 3. And what does this appear to do? Looks like it decreased by 6. Now, if it's a linear function, this one would have to go down 6 every time it moves over 3. I say over because these are x, and I say down because this is y, okay? And does this go down 6? Yeah, so down 6 over 3. How about this? Down 6? Yes, down 6 over 3. So the rate of change is down 6 and over 3. It's constant, and therefore this is a linear function. All right, let's look at this one. This one's going up, or sorry, over 2 for all of the x's. And how about this? What do you think this went up by? Up by 7. But is this going up 7? No. No, it changed in its steepness. This went up by 11. And then this one went up by 15. And we might be able to find a pattern for that, but that pattern is not linear. Not linear. And the reason is it doesn't have a constant rate of change. No constant rate of change. Right, so it might have a pattern to it. I don't know what the pattern is myself. But yeah, it ain't linear. It's not going to be a line. And if I did want to plot all of those points on a line, I would be able to then figure out that they don't make a line on a graph if I wanted to plot them. All right, last problem for today. Don't pack up, Devin, or you'll stay late. It says, which of the following equations represents linear functions? Now we said they could be written in the form y equals mx plus b. Y equals 3.8, I could write as y equals 0x plus 3.8. So that one's good. Y equals the square root of x is not going to be a linear function. Y equals 3 raised to the x is not going to be a linear function. Now this one's tricky. An x in a denominator I cannot write in this form because this x is in the numerator. Devin. How about this one? Yeah, if I distribute that, right? I could have written that as y equals 6x minus 6, which is in that form. So yeah, that's a good one. That's a good one. All right, so that's a linear function. It just wasn't written in that form. And this one has an x squared That is not going to be a linear function. No. All right, so all they're asking you to do when you identify these is based off of their equation. We'll eventually see graphs represented by these things. This graph, for instance, would end up being like this sideways curve. This graph, 3 to the x, ends up being like this infinitely long, steep graph. Y equals 2 over x, I think, ends up looking like this. It's like two little swoopty curves. And this one would end up being an upside down U shape, I believe. Oh man, I'm not hitting the point that I need to. Right, and those are not lines, but they're not asking you to know what those look like just yet. All right, well, thanks for watching, Internet friends. Have a great day.